7 participants on the call, including you. You are joining your conference as a participant. For a menu of available commands, press *#.
For attending the 4th webinar in the ZERH.
Your line is now muted.
On the Indoor airPLUS program. This webinar will be recorded and the recording will be sent out to all attendees. If there are any issues with audio, please write in the chat. And that can be generated by hovering over the bottom of your WebEx window and clicking on that chat bubble. My name is Erica DeLello, and I'm a project manager for NORESCO. This series is sponsored by the Colorado Energy Office and the High Country Conservation Center. And Jess Hoover is here to tell you a little bit more about that organization.
Thanks, Erica. Thank you to everyone for joining us today. As Erica mentioned, I work for the High Country Conservation Center. We are an environmental nonprofit in Summit County, and we have been very involved in supporting our community's new sustainable building code. We provide the energy consulting services listed on this slide to assist local building professionals, and we've been organizing educational workshops like this one to help folks learn what's required by the new code. We also partnered with the Energy Office, Energy Smart Colorado, and Deeper Green Consulting to sponsor a local HERS Rater training class so that we've got new HERS Raters ready to support your building project the July 1st implementation date of the new code. We are happy to continue supporting building professionals in our community with code compliance, and so we're really glad that you all have chosen to join us today. And with that, I will pass it back to Erica.
Thanks, Jess. So we've been working with the Colorado Energy Office to provide trainings just like this one. But in addition to those trainings, we've put together a code adoption toolkit that reviews the cost implications of changing code cycles, the benefits, other compliance resources, and a lot of other things. We are also currently working on a troubleshooting guide that will cover iCode conflicts and alignment, clarifications, and passive compliance. The Code Adoption Toolkit is already posted to the Colorado Energy Office's website, and the troubleshooting guide will be posted there soon too. If there's anything you review and you think that it could use more information, feel free to let me know, and we'll work to get that information included. There's also, we're about a little bit more than halfway on these Zero Energy Ready Home Series. We're also working with the the City and County of Denver to put on some trainings as well. So I'll be sending links to these resources and these upcoming trainings if you would like to register for those as well. And in addition to that, I'll be sending you a short survey with if you could please take the time to answer those questions. It'll help us continue to provide these trainings. I have muted everyone's lines to reduce background noise, but we do want to encourage questions, so please use the chat function and I'll let our presenter know at the end of the presentation. Today, our presenter is Robbie Schwartz, and he has been a champion of the building science industry for over 20 years. As principal of Build Tank Incorporated, Robbie works with builders of all sizes to ensure that their high-performance homes are efficient, healthy, and resilient. So with that, I'll let Robbie take it from here.
Great. Thank you, Erica and Jess. Really appreciate your guys' support, and really excited to move forward with this next section of our training series. The Indoor airPLUS program is as complicated and full of nuances as the Energy Star program, so we have a lot to go over today, and we probably will take the full time here. So this is our plan ahead. And we're just going to jump right in here with the basics for the Indoor airPLUS program. So the Indoor airPLUS program is a non-regulatory home labeling system currently for new homes, gut rehabs, and multifamily homes. So single-family, multifamily homes, and gut rehabs as well. It's designed to help assist builders and trade contractors and other renovators to be successful. It's really a concrete way for builders to sell the health benefits of the details that they're implementing in their homes when they're following these standards. It is independently third-party verified, and we'll talk more about that and they have a detailed set of construction specifications that need to be followed. As well, we'll look at the verification checklist, but these construction specifications are really where you're going to get the requirements of the program there. So again, just like Energy Star, we need to go onto their website and download this document there. The Indoor airPLUS program is an EPA label that adds health protections to the Energy Star and the DOE Zero Energy Ready Home program value propositions. So those two programs primarily are the energy side, as we saw last time, also a lot of with regards to water management. And this side of the equation ensures that we have a healthy indoor environment with the Indoor airPLUS program. So builders must first design the home to meet the Energy Star and DOE certifications. That's using that HERS index starting point to get that target score, and then they can dive into the Indoor airPLUS part of the program that really is primarily section 3 and 4 shown here, the comprehensive indoor air quality protection and safer, healthier home protection there. The IEP is respected as a benchmark for indoor air quality for occupants of new homes. It's a required part of labeling a house for the DOE Zero Energy Ready Home program, as well as the Passive House program. And optionally, if you're doing Energy Star, you could add the IEP and Indoor airPLUS program to that. But if you went the other route and really just wanted to do the Indoor airPLUS program, that would mean that you would also have to do Energy Star. So Energy Star doesn't require Indoor airPLUS, but Indoor airPLUS does require Energy Star as its starting point here. And like I said before, the DOE Zero Energy Ready Home program requires both Indoor airPLUS and Energy Star. So what ultimately causes indoor air quality issues in our house? A lot of it is moisture issues and moisture management and how we do that well. We've talked a bit about that in the past. Pollutant sources are another big reason for indoor air quality issues. Releasing of gas and moisture vapor and other particles in our houses. Inadequate ventilation. Ventilation has been a mandatory part of the code for quite some time now, but we still see houses out there that aren't ventilating properly there. And these symptoms may appear immediately or after some type of long exposure to these houses. We're seeing that people can get sick in their homes. And it's not just because the house is tight, but it's because they haven't really followed this systematic approach that we've been talking about and applied building science approach to create a house that integrates all these systems together to perform not only from an energy efficient perspective, but from an indoor air quality perspective. In our current era of COVID, we're seeing renewed interest in indoor air quality. We know that people spend up to 90% of their time indoors. The EPA claims that pollutants are often 2 to 5 times higher indoors than outdoors. And we also need to think about all the pollutants that we bring into our homes, on our shoes, with our pets, and then with belongings that we bring in, or furniture that we bring in, and as well as the things that we start with. So this program really primarily is about the construction of the house, but there is a homeowner occupation education kind of section of this program that we need to think about it. So to think about this in a little bit different way, Dr. Richard Corsi believes and has determined in essence that our average lifespan is about 79 years. 69 of those years is spent indoors, 54 of those years at home, 26 years in bed, 4.3 years in a vehicle, and only about 6 years of our total life, if we live to 79, is spent outside on average. So it's really important to think about what's happening in that indoor environment and how we're creating that indoor environment to live healthfully. You know, ultimately why it matters is it can really impact our emotional life, our physical life, our cognitive ability, and our respiratory breathing aspects. So, you know, total health begins, not only by exercising and eating well, but managing the built environment and where we choose to live here. So the ultimate strategies that the Indoor airPLUS program looks at here is primarily looking at source control, ventilation, filtration, and then I will add here education as well, because that is a part of the program, and we'll see that here towards the end. We need to educate the occupants of these homes to make them understand what they're doing and what they're bringing into the home as well here. A little bit of history of the program. It used to be a pilot program of the Energy Star, and it was called the Indoor Air Package that you could add on to the program. It had its construction specifications that were first released in 2008, and it was a partnership program with the EPA. It was a labeling program and required quarterly reporting. It's still a labeling program, and you still need to report with the program, and we'll talk about this a little bit later on as well, but you also need to partner with this program in the same ways that you partner with Energy Star and the DOE Zero Energy Ready Home program. Indoor airPLUS is on some revisions, so it's important that we know and are using the correct versions of the program and the standards that are associated with that version. Again, why versions are important is they help clarify, simplify, and improve the standards that we're working with. So the idea of these revisions is to stay a little bit ahead of code and to continually improve that value proposition there. So the current programs that we will be working with the DOE Zero Energy Ready Home program are the Indoor airPLUS version 1, revision 4, the Energy Star version 3, revision 10, and the DOE version 1, revision 7 of the program. So when you're downloading documents for these programs, you again make sure that you're downloading the right versions and revisions of the program. It's pretty hard not to because they don't really post the old versions anymore there. Just a little bit of history from the revision side of the Indoor airPLUS program. It was originally, revision 1 was released in 2013. Again, it helps simplify the checklist and create better connection with the Energy Star program. Revision requirements are based on new science and technology that's coming back and feedback from the industry on the program. Revision 2 was released really in the same year. It created an alternative for this garage separation that is required there and how to demonstrate compliance with that, and an exception for slab-on-grade homes with regards to radon control in that house. Revision 3 was released in 2015. Again, getting better alignment with Energy Star and Energy Star's continued revisions, in this case, revision 8. It helped clarify, as we've talked about, and then it ultimately helped create some new resources, specifically this resource that's shown on the right here, which is a resource guide for how to get compliance with low emission products that are required in the home, and we'll spend a lot of time on that. And then we get to revision 4 that was just released a few years ago in 2018. There's some new exceptions for humid climates and dehumidification and pipe insulation, some information about hard surfaces on flooring, update on the radon section as well here. And we'll go through, really what we'll be concentrating on today is this revision 4 of the Indoor airPLUS program here. The Indoor airPLUS has a checklist format to demonstrate verification for the program. It's a little bit different because this is jointly filled out by the builder and the rater or third-party verification organizations that are doing it. The rater must maintain and retain this checklist and ensure that it's getting filled out properly. And it enhances both short-term and long-term programmatic verification and quality assurance with the program. So you cannot get a label and certification with the program unless this is filled out and filled out properly. You'll also see that in version 4, they have some of these exceptions or these other checkbox that need to be filled out as well. So in the earlier versions, it was just how it was verified, if it was compliant or relevant for that particular house or non-applicable, who it was verified by. But now if you're offering an exception to the program requirement, you need to detail that as well. And those are kind of all those areas that are highlighted in yellow on the checklist. But again, the checklist doesn't necessarily tell you everything that's required by that particular component. So you really need to go into the construction specifications as well here. So there are really 8 main sections to the EPA Indoor Air Plus program, starting with that Energy Star compliance, demonstrating compliance. And in this case, really, it's more compliance with the DOE Zero Energy Ready Home HERS target score is what we're talking about there. Then we have the moisture control section, the radon, the pest, HVAC systems, combustion pollutants, materials, and then the home commissioning and homeowner education side of the program. So these are the things that we're going to go over, except we already have talked about the qualification using the Energy Rating Index score qualification for the DOE program, so we'll skip that today. The construction specifications are formatted as shown on this page, so that it talks about the relevance of the Energy Star checklist in those programs. It gives you additional Indoor Air Plus requirements that are required, and then some advisory notes that talk about exceptions to the program when applicable here. Again, it's super important to get this document that shows the construction specifications, what they are, and that's really what you'll be following there throughout the program. The Energy Star checklist are referenced inside of these construction specifications using the acronyms that are listed below and then are demonstrated in the blue circle on the right here. So that's for the HVAC design report requirement in this HVAC sizing and design section of the specifications for the Indoor Air Plus program. There are some exceptions that are demonstrated in the specifications. There's a note section that provides additional information and clarification in the specifications, and then an advisory section that provides additional guidance to be considered for specific requirements there. Again, spending some time with the specifications is super important, and understanding how the program is ultimately set up. That's what we're trying to do here today. You have to complete this verification checklist. Energy Star certification is required, again, in order to achieve Indoor Air Plus. And then with regards to the DOE program, both Energy Star and Indoor Air Plus are requirements of that program. Only one checkbox is checked per line. You can use the non-applicable section for those things that don't apply to that particular house. But anything that is relevant to that house is a mandatory item on this checklist. The checklist can be builder verified or rater verified, but really it's the ultimate responsibility of the rater or a third-party verifier to manage the checklist and make sure that it's filled out properly, and then ultimately retain that checklist, turn it in for certification, and follow up with the labeling process for that particular home there. Verification checklist, there are a lot of different items that may be verified visually by reviewing photographs taken during construction or by checking documentation, especially with regards to materials. That becomes a really important part, is looking at the documentation that demonstrates that certain materials like OSB or paint or other finished materials have low VOC content or low off-gassing. That all happens through documentation review. And then there are other methods that you can create to potentially streamline the process to make it work and work seamlessly during the construction process here. But verification is a huge part specifically of this program here. So looking at the checklist, again, this is an example of the radon portion of the checklist. There was an exception that applied for this because it was, in this case, it was built in a dry climate zone. And they used perimeter aggregate and drain system, in essence, to pull radon gas out from underneath the foundation here. So it's just an example of how to fill out the checklist. Verification, so all items items verified by the builder shall be verified for each qualified home. Most likely, most of your homes are one-off or custom homes, so a unique checklist is needed for each home. And even if you're doing a more production-style environment, you need a unique checklist for each home. The Rater Verified provides the Indoor airPLUS label again. The verifier is providing that label, so we have to get that label to the builder, and the builder provides the buyer with the label and an information kit about operation and maintenance of the house, kind of a homeowner's manual for that house. And then also remember that the rater has to keep documentation from the program for at least 2 years, which pretty much follows the ResNet standards for the keeping of documentation for anything that you've done a energy rating index score on. Multifamily buildings can be accredited and certified through this program as well. You'll need to go to the multifamily section of the program documents, and we're not going to spend much time. I just wanted to make sure that you knew that that was available if you're working with any multifamily units up there. Okay, so let's move on to how do we actually build and verify Indoor airPLUS program requirements. So again, these requirements revolve around moisture and materials, combustion safety, ventilation and filtration, radon control, and pest management in our houses here. So after you've qualified for the program, doing the HERS target qualification, you start out looking at moisture control issues. Now, the moisture control issues are super important because they are really the leading cause of health issues inside of our houses, primarily because moisture can lead to mold growth. So about 19% of U.S. households have at least one person with asthma in our houses. There are about 20 to 50% increased risk of asthma in damp houses, so that moisture control, again, becomes super important. There's an economic cost to asthma and other health issues that are associated with moisture damage in our homes. The mold growth is often what we talk about, and we'll talk about that in more context right now. Mold obviously is very common in buildings. There's always a little mold everywhere in our houses, but we're trying to ensure that that mold isn't going to bloom or grow. Basically, mold grows almost anywhere, but it does need a food source. And wood and paper-based products are that primary wood source, but you can get food source for mold just on dust, on paint, on wallpaper, on drywall, carpets, all kinds of surfaces can hold what mold needs to ultimately grow. But mold needs not only the spore and the nutrient, it needs moisture and the proper temperature to grow. And the things that we can control really are the moisture and temperature range inside of our houses. So if we can keep that moisture content low, we can avoid mold growth in our houses. So mold growth, again, from a moisture control perspective, a thermal control perspective, an air control perspective, is really from a building science perspective what these programs are trying to do. They're trying to gain that control and predictability, again, of moisture, thermal flow, and airflow inside of our houses, and ultimately promote drying mechanisms over wetting mechanisms so that we don't have those moist surfaces or moist air content to help and allow mold to ultimately grow inside of our houses. From a verification perspective, again, a builder or rater can verify these. They're visually verified during pre-slab inspections potentially for radon systems, review the documentations, and look at free drainage soils. We'll look at this section in a lot more depth here, starting with 1.1 on the checklist here. So drainage systems we've talked about in the past. They're a requirement in the IRC, they're a requirement in the Energy Star program, therefore they're a requirement for the DOE program, and they're also a requirement here at the Indoor airPLUS program for moisture control. Requiring that site and foundation drainage systems. We're again trying to figure out how do we get that moisture to drain down from our roof system, down from our wall systems to the site, and then ultimately away from the site. You might need an interior drain system with a sump pump to make that happen, and there's guidance inside of these programs in order to make that happen and happen well. From a capillary break perspective, that's the 1.2 section here. We need to install some type of polyethylene sheathing, potentially extruded polystyrene, some type of vapor impermeable sheathing beneath concrete slabs. We need to install capillary breaks in our crawl space floors. We need to install the right aggregate underneath these sheathing materials, or potentially use an alternative path because the aggregate not only helps drainage, but it helps promote our radon systems here as well. So when we're talking about capillary breaks, we're talking about ensuring we get the right things installed at the right time. So sequencing becomes super important there to get that not only the aggregate installed, which doesn't happen as often as you would think. So you might have to change your specifications to make sure that gets installed right. And then the capillary break underneath that foundation, as we talked about last session as well. In these locations, as well as potentially at our sill plate to foundation connection to make sure that that capillary break, remember that sill seal is primarily a capillary break material, not an air sealing material, and between our foundation stem wall and our footings as well here. Now, this isn't necessarily a mandatory requirement here. This would be best practices to get it at the footing to stem wall connection, but underneath the slab component, that is a mandatory part there as well. Foundation walls, basements, and crawls. We're talking about all finished masonry and concrete walls need to be damp-proofed. Crawl space and basement perimeter walls, we need to make sure that we're limiting or preventing air infiltration in those locations, and then insulating those components properly. Now, this says at a minimum to R5, and that's just because you are allowed to use the UA trade-off approach to be able to trade off R values and U values at your foundation, potentially for a greater R value above grade. They just want to make sure you don't, you're not able to trade off all the way to zero insulation in those components there. Ventilation needs to be provided. Conditioned air at a rate. So if you're doing like a ventilated crawl space, for example, instead of a conditioned crawl space, which personally speaking doesn't make sense at all. You always want to do a conditioned crawl space, but if you do a ventilated crawl space, it has to be ventilated correctly, and there has to be clear separation between the conditioned space, or the thermal boundary between the conditioned space and that ventilated crawl space there. We're not going to talk about dehumidification because it's really a moist climate zone issue, but we need to know that there are prerequisites and requirements if you are in those areas. But as we talked about last time, the IRC has lots of requirements for damp proofing, getting proper drainage around our foundation systems that need to be followed. Unvented conditioned crawl spaces are talked about in the IRC and the IECC, ensuring that we get that capillary break, or that separation with a strong vapor retarder that's sealed to the perimeter walls of those systems there. A verification perspective, again, the rater or builder can verify these components. You can verify during pre-drywall inspections, review documentation as well here. So our next section is combining all of these sections together for wall drainage systems. So we need to install a drainage plane behind our wall cladding, install flashing materials at the bottom of walls, at windows, at other openings, and direct that roof water. We're using gutter systems away from our houses. For homes to meet the Energy Star exceptions for gutters and downspouts, provide protection for water splash damage by one of the following means there. Again, that takes you back to the Energy Star program and that linkage between Energy Star and the IAP program is primarily here in this water section, but the difference is that the Energy Star program's builder water management checklist isn't a verified checklist, whereas all these components are being verified potentially by a third party, but definitely by the rater or by the builder using the Indoor airPLUS checklist in this case here. So again, talking about proper flashing details, drainage planes, potentially rain screens, other components in that assembly. So water management flashing materials here, as we talked about last time, this is from the Energy Star checklist, but again, it's asking for the same thing here as it's asking for from the Indoor airPLUS program here. Gutters and downspouts are a big part, so making sure that we get our compaction done properly, that we are draining away from the site, that we're not trapping moisture that's going to wick down into the soil near the foundation and potentially wick into the house here. So getting our gutters routed away from the house at least 5 feet, or putting some type of perimeter drain that's going to catch the water coming down from the house and direct it away from the house, potentially to some type of cistern or pumping station as well can be done. We talked a little bit about that last time as well here. Water management roofs, so we're fully flashing all roofs at their intersections, installing bituminous membranes at valleys and roof decks. There are some exceptions for dry climates, but generally speaking, it's needed in our high altitude climate zones. And we're trying to mitigate against any type of ice damming in those eave sections there. So as we talked about last time, the requirements in the builder water management checklist is getting that self-adhering membrane up 2 feet from the wall section. So you might be actually laying down 4 or 6 feet of the material depending how long your eaves are, but you're getting it up above the warm, in essence, the insulated portion of that roof line there. Moisture protected systems verification perspective. Again, it can be builder verified or rater verified using visual verification at pre-drywall for piping materials. So we're talking about installing moisture resistant backing materials behind tubs or shower enclosures. In this case, installing corrosion resistant drain pans, and then there's some exceptions there that you can see down below here. So again, as we reviewed last time, the same thing that's on the builder water management checklist, making sure that we get the right backing materials behind wet areas and inside of our homes, generally speaking bathrooms, that we're sealing those things up well, that we're not going to have any repeated wetting, potential mold growth in those areas, and then corrosion resistant condensate drainage systems in these assemblies here. Vapor retarders are talked about, so don't install class 1 vapor retarders on the interior side of below grade walls. So if you are insulating below grade walls, you need to figure out some system that allows drying potential back into the inside. So if you're insulating from the inside, this again is a perforated fiberglass blanket. It does have vinyl or class 1 retarder on it, but it's been perforated so that it can still act as an air barrier, but it has a permeability of about 10 perms to allow moisture to dry out from that foundation back into the house there. That's the big thing that we're trying to avoid, is any trapping of moisture that could cause indoor air health issues or potentially building durability damage in those houses there. That's a close-up view of those holes. It's really a pin-sized type hole, one every square inch at the corners of every square inch of this material. You can also insulate from the outside. If you do build with traditional vapor retarders above grade, you need to make sure that those vapor retarders are installed properly, that the seams are overlapped, that you're using some type of flanged electrical box that you can seal it to, that it's sealed to our top plates, our bottom plates, and to our openings. And then you need to figure out how are you going to get that vapor retarder management system installed in difficult locations like at rim joists, or potentially for some reason we often don't install these systems in bathrooms and other locations. So the continuity of this system is super important, and how well it's installed so it can stop vapor transport by diffusion, but also, unfortunately, it also needs to stop vapor transport by air leakage. So for allowing air to bypass these systems, we're only going to end up trapping moisture into those assemblies because more moisture moves by air movement than it does by diffusion, as we learned in the past here. Materials with signs of water damage can't be used inside of our homes. So don't install building materials that have these visible signs. Don't enclose framing members that have high moisture content, above 18% is the minimum requirement. For wet applied insulations, make sure you have the ability to allow those materials to dry completely there. A lot of this comes down to storage of our materials. We need to store them properly so that they're not going to get wet and retain that moisture before we start building with them. These are examples of materials that have signs of moisture damage already, and you can't use those materials. And then you might have to invest in a moisture meter to be able to test materials to ensure that you can, that it's safe ultimately to cover them up there. Especially if you're using a vapor retarder, class 1 or 2 vapor retarder in your systems, it's super important to measure the moisture content before you're covering them up. But remember, the program says anything that's less than or equal to 18% you can cover up. I would suggest it be even drier there. Moisture-resistant materials from a verification perspective, the hard surfaces here, again, can be visually verified or by the builder or the rater. And this one itself probably is only able to verify at a final stage of construction. But you want to make sure that you're not allowing your occupant to override you there, because this one feature here, which is basically saying only allowing moisture-resistant hard surfaces in kitchens, bathrooms, entryways, laundries, all these areas that are potentially moist. I've seen this derail a project certification because the builder allowed or didn't have a discussion with the home buyer beforehand, and they installed carpet in that bathroom, and the home buyer would not remove the carpet, so we couldn't certify the house, and it was the only thing that was that really impacted certification there. So in Summit County's perspective, it's actually a code compliant issue. Okay, so this moisture control, the benefits are again from water damage reduction, flood mitigation, structural durability, reduces potential of mold growth, which is a big contributor to asthma in people's lives, fewer maintenance issues from peeling paint and moldy grout and other things. Now, all these things have multiple benefits for the home buyer, but largely from the perspective of the Indoor airPLUS program, we're trying to limit mold growth and things that will ultimately impact a person's health inside of our houses here. But long-term durability of the structure is a big component of that. Okay, going into the second section here, radon. Radon is a big issue in our houses. A radon system is required in Zone 1 radon situations, and I'll show you how you can find that. But it is also recommended in all zones. it turns out that almost all of Colorado is located in Zone 1, so we see a lot of radon systems needing to be installed. Verification needs to start at the construction document stage to make sure that a truly approved mitigation system is being designed for that house and then ultimately is implemented in that house during visual inspections before pouring the slabs to make sure that that's all working, and or through pictures, other methods that you can use to verify that system here. So radon is a cancer-causing radioactive gas that's created during the natural process of the breakdown of uranium. And basically, uranium is part of granites, and granites type rock is probably the predominant type of rock here in Colorado. So that's one reason why we have so much radon in our environment. Radon can be found everywhere in the United States. 1 in 15 homes have radon that's above 4 picocuries per liter, which is the action level that's been set by the EPA there. So if you have radon gas that's above 4 picocuries or 4 picocuries or above, and you did a test in an existing home, you would be required to mitigate that in an existing home. And we're seeing lots of homes that are now doing radon testing at the time of inspection at resale. So we're seeing a lot of radon systems being installed. You're most likely to get your greatest exposure of radon in your house because we tend not to ventilate our houses well, and we also don't do a lot of radon-resistant construction techniques here, which we'll be talking about here soon. And it's the second leading cause of lung cancer in our houses after smoking there. So it's a big topic. It's getting more and more resonance in the construction industry. The code actually has an Appendix F that deals with radon construction, but jurisdictions have to consciously adopt an appendix in order to make it a code requirement. So in this case, because it's part of the Indoor airPLUS program, and the Indoor airPLUS program is part of the DOE program, it is a mandatory requirement to do radon construction in Summit County. Some of the things that we're talking about here are making sure that all penetrations through the slab, including sump pit covers, are sealed and made airtight. Construct that home that's built in their EPA Zone 1 as radon resistant. Active systems are not required, but they're recommended, but a passive system is required in Zone 1, but recommended in every house there. And then some type of homeowner education makes a ton of sense. They used to have a requirement that you had to also test the house, but you don't have to. That's not a requirement anymore, but they would like you to consider offering testing to the occupants that are going into that house so that they know if the passive system is going to work well enough or if they need to make that passive system active as an option there. So radon control, this is the radon zone map here on the right. You can see Zone 1 is the red area, and you can see almost every county in Colorado is Zone 1, and every county in Colorado is at least Zone 1 or 2. So again, it's highly recommended that regardless that you put a radon system into the houses here, specifically a passive radon system in our houses. So the idea of a radon system is that you're able to collect the gases underneath the foundation slab before they have a means to rise up into the house through penetrations in that slab. Because again, if you remember our building science section here, stack effect is always working on our houses here. So any air that leaves on the high side is generally replaced by air coming back in on the low side. And that low side could be air and the gases that are traveling with that air coming up into the house here. So it uses this pipe that's installed underneath the foundation, going through the conditioned space of the house to the outdoors, and is using, if in the passive system, is just using stack effect or that warm pipe to influence and cause that air to rise up and out of the house. Any air that leaves through that pipe has to be replaced, so air is coming back in through the soil underneath the foundation and cleaning that air, or basically taking that radon gas out before it has a chance to move up into the house here. So we'll talk more about that here. Now, in revision 4, there's been some updates to the section that came from this ANSI standard here. So it could make sense for you to take a look at the standard here, although it's spelled out pretty well in Appendix F of the IRC and in this section 201 of the Indoor airPLUS program here as well. Radon control is, again, using a soil gas collection plenum or vent pipe through our house, some type of fan or at least an electric receptacle near that system so that you can retrofit a fan into the system if needed. If there are elevated levels of radon in the house, then you can make your system active and draw those levels down. Right now, you're allowed to install either a passive or active system. Passive systems generally work pretty well, especially in an airtight house. Passive system must have, however, that electric outlet provided close to that pipe there. Now, that fan and electrical outlet have to be outside the pressure boundary or thermal boundary of the house as well, because they don't want you to suck, or in essence, the sucking side is fine to be inside, but on the outward side of that fan, you're in essence pushing the air out of the house. And if you located that fan inside the building thermal envelope and there was a leak in that pipe, you would actually be distributing or pushing radon-laden air into the home. So it's a safety mechanism to ensure that that fan is always installed outside of the building thermal envelope and pressure boundary of the house. So basically the air barrier system of that house. Radon control systems, if you can't find a location in an attic or you don't have an attic, you can locate that fan outside of the house as well. This picture is showing the fan located in a garage attic instead of the attic over the conditioned space of the house. So this is all acceptable. But if you have a normal attic area, you have to have provide an attic area where you can install a radon fan, which means you need to follow these guidelines for the amount of area that you have around that potential location for the fan and the electrical box that's associated with that fan. Remember, regardless of if you install the fan or not, you have to provide electrical there so that you can plug that fan in and get power to the fan if it were to be installed there. So here's an example of some possible locations for the fan. You can locate that fan outside the boundary of the house in the garage or the attic there, or just completely outside. You can't install it in a conditioned crawl space or conditioned basement or any type of conditioned living area inside of that house there. Now, gut rehabs, you often see radon fans installed like this. This works. Again, you want to make sure that discharge pipe isn't too close to any window or vent that would bring that radon gas back into the house here. So if you remember our 10-foot, 3-foot rule for intakes for ventilation systems, you kind of basically follow that same rule here. Ideally, you're getting that fan up to the tallest roof line there, so you're allowing it to get to the ambient air, not just a location where it could come back into the house here. Not to talk too much about gut rehabs, but anyway, if you have a really large house with a large foundation, there's some guidance for that as well. And there's this document that you can get to learn more information on how you might have to address a really large foundation versus a traditionally smaller footprint there. So when we're talking about a radon system, basically from soil to roof, we begin at our soil level by getting a nice smooth foundation there underneath within our foundation walls, and then adding aggregate, clean aggregate to the system so that radon can flow through that aggregate ultimately to the pipe that we're putting in there. So you have to have 3 or 4 inch diameter gas tight vertical vent pipe, and you have to label that pipe properly. You also at the bottom inside the aggregate have to have some type of key fitting there, and that has to be below the capillary break there as well, or air sealing mechanism. Then you have to put at least 10 feet of horizontal perforated drain tile connected to that T-fitting so that you're able to collect the gas underneath the slab there. And then you install that polyethylene sheeting. That sheeting is not only a capillary break from a moisture perspective, but it also creates a suction layer, in essence, a boundary, an airtight boundary between the house and the radon system layer, so you can actually pull gas and you're not pulling it up through the house here. You need to extend that pipe at least 12 inches above the roof line there, and then you have to have the ability to install a radon fan there, and there's some issues with that radon fan. And then lastly, you need to seal that foundation and caulk any penetration through that foundation at expansion joints where it might crack, at sump pits, at the connection between the slab and stem walls. All these locations need to be air sealed and caulked with that location. So here's an example there. This is the exception here. So if you don't do it in the way that I just described, you can use this perimeter drain system potentially as a way to collect radon gas there, but you need to tap in that. Now there is this other note that we need to look at that basically says that suction points are not permitted on sump pit lids. So that's happening in this picture here. So if you penetrate the sump pit lid, that pipe needs to go all the way down to the pipe that's at the drain tile there, so that you're not just sucking from the sump pit lid, that it's actually connected to the system there. So here's some examples of airtight sump pit lids that need to be associated with that, and then the one example of the sump pit lid that's pulling radon. That's a questionable install. You have to verify how that's installed and if that can actually work or not there, because there is an issue that we just talked about there that's documented in the program specifications here. So radon, the benefits, ultimately protecting against radon gas. Again, the second leading cause of lung cancer. So we obviously want to make sure that we're not getting radon gas into our houses there. Pest barriers, pretty straightforward. We want to keep these pests out of our houses, potentially from nesting there or creating other pathogens that can help make us unhealthy inside of our homes. These systems can be builder or rater verified. Visually verified at final inspection is usually when that happens here. So we need to make sure that we're sealing all penetrations and joints between the foundation and exterior walls so the pests aren't getting in there. Air seal those sump pit covers so pests can't come in that way. And make sure that they're all provided with some type of screen there. It's not required at the dryer vent because we don't want to capture lint and other things there that potentially could cause a fire, but otherwise we need a corrosion-proof rodent bird screen for all openings that can't be sealed using caulks or other sealants in the house here. So the benefits here are preventing the potential damage from pests, less vacuuming and dusting, and then less allergens and other things that trigger disease and asthma that can be created by pests, waste products and other things that they bring in to our homes here. HVAC systems. Here we're talking about the indoor relative humidity and control of that relative humidity. Again, this is generally a moist climate zone issue, but humidity greater than 60% inside of our houses can cause big problems in our houses here. And so in Colorado, we tend, especially when people come from out of state and move here, they tend to want to humidify their houses, and we need to educate them and help them understand why we don't want super humid houses here. HVAC components in walls or cavities in garages can expose occupants to other issues, from molds, carbon monoxide, to connections between our house and garage. So we'll talk about that. And then filtering our systems makes a ton of sense, and that's why the program requires at least a MERV 8 filter in our houses. So as we talked about last time, this program requires proper HVAC sizing that involves around calculating the heating and cooling loads in our houses, selecting the right equipment that has the proper capacity to meet those loads, and then designing how we're going to distribute those loads around the house, either by pipe or duct, or however we're going to do that in our particular house here. So proper sizing happens through the ACA manuals or the ASHRAE Book of Fundamentals. In warm climates, again, keeping that humidity down low. Now, there's been some really interesting research that's just come out that we need to talk about here, because from a house perspective, we basically want our houses to be as dry as possible, because we know that moisture and repeated wetting of our houses are the things that destroy houses over time. So we know that air and vapor are one, that we need to control the surface temperature of that first condensing surface, and ultimately control the airflow in that house and the moisture that's flowing with that air. But the research has shown that there's some real health benefit to having the humidity level in this kind of sweet spot of 40 to 60% relative humidity. What we see is that the higher humidity air has larger water droplets, and these water droplets fall to the floor there. So what's carried by that water droplet is also falling to the floor. So we basically have less ability for disease that's transported by air to pass those air particles onto a person. So we can actually create a more healthy environment if we have slightly higher relative humidities than we might want from the perspective of building performance here. And that's, ultimately why the Indoor airPLUS program is saying ensure that your relative humidity is below 60%, because anything above 60% is going to cause moisture damage and ability for not only molds, but potentially structural damage in our houses. And again, in our climate zones, you're going to be pumping a fair amount of moisture into our houses to get to 60%. So trying to maintain at least that 40% could make sense, but you have to balance what the house needs and what the occupants' needs are there. But again, the Indoor airPLUS or Indoor Air Package has Plus program, has this specific requirement of less than 60% humidity. So again, we have to follow Manual S here. Manual S is really trying to do something fairly simple here. It's trying to ensure that the capacity of our system is able to meet the load, that we have chosen the correct equipment, not only from a humidity perspective, which is the main reason why the program is trying to do that, but to make sure that we have good distribution of energy in our houses. We want our system to be right-sized, not oversized or undersized, so we're short cycling or we're creating other issues in our HVAC systems in our houses. So going through those 3 steps of getting our loads, choosing our equipment properly and then designing distribution systems makes sense regardless of the type of HVAC system you're going to install in that house. Now, these systems can be verified. Mainly, it's verified by the rater here. So you can see that although some items can be verified by the builder, in this section, you'll see the builder section there is grayed out, so the builder can't verify this. You're verifying documentation through the Energy Star program if you're using the rater verification reports or visually verifying these systems. So design all duct systems according to the ACA Manual D. Again, if you're using duct systems, they have to all be inside the building envelope with some small exceptions of about 10 feet there. Ensure that all duct systems are tight and have been tested and verified to be tight and balanced so we don't get high room pressures or low room pressures, which is another requirement of the program. Don't use building cavities as part of the forced air systems. That's also a IECC mandatory requirement that says building framing cavities should not be used as duct systems. You can see the problem shown in the report here. You might come across a contractor that will take you to this section of the IRC. This R101.4 is in the IRC. I'm sorry, this section, R101.4, is in the IECC. It's actually in every code there that basically says the most restrictive shall win, but there is a section in the IRC that creates some confusion about the ability to use plenums as pressurized ductwork. Plenum can be defined as a building cavity, but the way that it's used in code is really meaning a ducted building cavity there. So some contractors you might come across that say, well, I can use a building cavity. Well, the most restrictive should rule. So if you go to this section of the IECC, it's very clear here that you can't use a building cavity as a pressurized duct system there. The duct systems if you are using duct systems, they have to be covered and protected during construction. And then after construction, they need to be cleaned there. So that's something that you might have to add to your process, is actually cleaning the duct system there. Somebody has an unmuted phone, so if you could mute your phone, that would be greatly appreciated. So cover up those duct systems and move on here. So verification, again, just by a rater, can be visually verified at a pre-construction stage here. This is saying do not locate air handling equipment or ducts in garages. And note that ducts may be located in building cavities adjacent to the garage there, but they need to be separated with a continuous air barrier system. So these are some examples of what the newer codes are allowing. Some way of installing the duct, if you're going to install it in the garage, some way of ensuring that the duct is inside the air barrier system of the house here. No air handler equipment or ductwork installed in garage, so this is how that would be verified. Provide mechanical whole house ventilation systems and then test the airflow of those systems. Outdoor air ducts connected to the return side of the air handler should be used if you're doing a supply side ventilation systems. You need to make sure that what your air temperature is and that you're tempering that air and that you're using a you're using an ECM motor if you're doing that, because that's another code requirement that's not specific to the Indoor airPLUS program. And then the EPA recommends a higher MERV system as well, a MERV 13 system, and we'll see why that is. Everything needs, there are basically these three types of whole house mechanical ventilation systems that we talked about last time: exhaust ventilation, supply ventilation, or balanced ventilation systems. Remember, they all need to have some type of control system installed as well. So when you're providing local exhaust ventilation systems, they need to be vented to the outdoors there. And dryers as well need to be vented to the outdoors as well. So we talked about that a little bit last time about the IRC rules about venting everything to the outside, making sure that they're following that 310 rule so that none of those byproducts that you're venting to the outside are able to come back into the house. This includes, in this program, this includes the range hood. Even though there is this loophole, in this program, the range hood needs to be ducted to the outside. And at a rough stage of construction, it's often really good to verify that you have at least a 6-inch duct that's going to duct that range hood from the outside. If you're using some of these commercial quality hoods that push really ungodly amounts of air, like 1,000 CFM, 1,500 CFM, you're going to need a larger duct than six inches. But at a minimum, a 6-inch duct needs to be installed. These other exhaust systems, as the program talks about, for dryers need to be ducted all the way to the outside there to get those pollutants to the outside. This can all be verified at inspection, either at rough and final or a combination of both. Again, it's rater verified, not builder verified here. Filtration systems. We talked about having filter access points that are gasketed and airtight that ensure that the air is moving through the filter and not bypassing the filter there. The EPA recommends higher MERV filters, but they don't require that. You only have to use that MERV 8 as a minimum requirement there. And then there's some requirements for that filter access there. Again, being airtight, ensuring that it's gasketed and that the air is flowing through the filter. So MERV stands for minimum efficiency rating value. The higher that MERV number, the more ability that filter has to filter out smaller particles and pollutants that's in that air. Again, the higher the number, the more resistance to the airflow, however, there. And that resistance to airflow can cause problems in the distribution of a forced air system there. The higher the number, the more effective the cleaning that air is. And you can see here in the picture on the right that you can get filters that actually are able to filter out bacteria and viruses that are in that air. So getting those higher MERV systems can be very worthwhile to consider, but you have to consider what is it doing to restrict the flow of air in that house. So there's some tricks to think about. So this restriction of the flow of air is dictated by the pressure drop across that filter there. And what we see from the difference between a 1-inch filter and a 4-inch filter is that the surface area of that filter is increased so much. So in this case, we have 2.7 square feet for a 1-inch filter. When you go to a 4-inch pleated filter, they might both be the same rough size, being a 20 by 20 or 25 by 25 filter. Its surface area increases tremendously because it's a pleated filter. So we have 8.5 square feet. And you see that the pressure drop in the diagram to the right of the 4-inch filter that's in green versus the 1-inch filter in red is significantly less there, just because of the greater surface area. So again, that pressure drop equals the resistance to the flow of air across the filter, which can have some negative impacts on whatever type of airflow system that you're filtering here. Also, 1-inch filters need to be replaced more often than 4-inch filters, so another reason to consider a better quality, bigger filter in your systems there. You can find filter information in these performance data sheets. However, these performance data sheets aren't easy to find in themselves. But if you can find a performance data sheet for the filter brand that you like to use, you can figure out what is the medium square footage of that. And you can see on the 4-inch filter, you know, I've got a filter that has 37 square feet of area there. You know, the pressure drop there is minimal. You know, it's less than 1. So picking the right filter makes a lot of sense here, and higher MERV rated filter as well. Now, verification of this can happen by the builder or rater. Usually it's through visual verification at final, because you want to make sure that filter, you're using the correct filter when you're turning the house over, so that it's more likely that the occupant will buy the same type of filter that's currently in the system. It's not always the case, but it's more likely there. But again, you need to do some education with your buyers to ensure that they're filtering the air properly, whether you're using a forced air heating and cooling system or just filtering ventilation air that's coming into that house. So the benefits from the HVAC side are reduced exposure to mold and mildew through better filtration, better sizing of the system, better humidity control inside that house, increased comfort with longer run times from properly designed systems. Again, filtration can remove allergens, toxins, bacteria, viruses even, depending on the filter that you get. And ultimately, the house stays cleaner if we're filtering that air there. Combustion pollutants is what I'm trying to say here. Really, we're starting to talk more and more about source control as we move into combustion of pollutants here. Carbon monoxide is a huge issue because we have natural gas burning inside of our houses. We want to ensure that we're not getting carbon monoxide, which is caused by incomplete combustion of these burning products that we burn to heat our houses or just create ambiance inside of our house. CO poisoning kills way too many people. It shouldn't be happening, but we can help prevent that by creating or installing safer products in our houses, burning products in our houses. Nitrogen dioxide is another big one. This is primarily from burning kerosene and woods. It also is created when we're cooking as well. And then other particles can be directly emitted into the indoor through wood stoves and fireplaces and whatnot. So venting, all these systems become super important to think about. Mechanical draft or direct vented systems are what's required by these programs. So if you're using furnace, boilers, however you're heating water, they need to be mechanically drafted, direct vented, which is in essence sealed combustion or direct vented appliances here. Although a direct vented appliance isn't sealed combustion, it has a safety mechanism. If that system were ever to backdraft, it automatically turns off the system there. So it's a combustion safety issue, really, is what we're talking about here. Fireplaces are mechanically drafted or direct vented, or rater verifies maximum allowed exhaust flow. If you're using a wood fireplace, you're basically doing combustion safety test to make sure that you can't backdraft that fireplace there. You were ensuring that fireplace doors meet all the issues here, and then meet emission standards and restrictions for fuel burning appliances as well. Fuel burning appliances and space heating appliances, we're talking about traditional masonry fireplaces and factory wood burning fireplaces. It doesn't necessarily eliminate the ability to use these systems, but you need to follow the construction specifications of the Indoor airPLUS program to install those. Same with wood stoves, wood fireplace inserts, pellet stoves. Again, go to the construction specifications. And even if you're just installing a natural gas or propane fireplace or some type of decorative log set, again, you need to follow the construction specifications that are laid out in the Indoor airPLUS program construction document there. Combustion equipment, there's an example of the sealed combustion furnace, a direct vented water heater. And the direct vented water heater, you see at the very bottom, That's the combustion chamber. It's open to the house, so it's not sealed combustion, but it does, again, have that safety mechanism. So wherever to try to backdraft, then it turns off the system here. Stoves, again, and fireplaces, it doesn't preclude necessarily the ability to use wood-burning stoves and fireplaces, but you need to follow these standards and guidelines that are in the construction specifications. From a verification perspective, this is a radar verified item, primarily using documentation, but also visually verified here as well. So make sure that you're, as a builder or as a rater, that you're speaking with your builder about saving this documentation and how they're going to save it. And I'll give you an example of how to do that later on. Regardless of if you're using sealed combustion or power vented appliances, any type of house that has a fuel burning appliance in it also must have a carbon monoxide detector in it. And it's important to understand the different types of carbon monoxide detectors. Most carbon monoxide detectors don't sound at very low levels here. And low levels of carbon monoxide can be quite unhealthy for the occupants. So if you go to this website, coexperts.ca, you can get more information on that. But the carbon monoxide alarms that they make, that CO Experts, are amazing at how well they work and how they can pick up low levels of carbon monoxide in a house here. Verification for carbon monoxide is generally done at final to do CO alarms, and if you have to do any type of carbon monoxide testing, you would do that also at final as well. Multifamily is also looking at smoking restrictions in these buildings, and so you can look at those requirements if you're working on any multifamily building. This is also talking about verification for multifamily buildings, so again, go to the construction documents there. The next thing we're going to talk about is garage separation. We've talked about this. It's a mandatory requirement of the IECC and the DOE program to separate the garage from the house, but the Indoor airPLUS kind of adds another dimension to that. You can isolate the conditioned space from the garage by air sealing it, making sure that there's no HVAC equipment or ducts in that garage, making sure that you have properly weather stripped and automatic closures on the doors between the house and the garage there. You can also use an approved ventilation strategy and testing method to ensure that that garage is separated from the house there. So there's kind of two strategies. Both get verified and ensured that that garage is actually separated from the house. So this just reviews what we just talked about to ensure that we have the system there. If you're testing the house, you have to have a fan located in that garage that can depressurize that garage. Usually a 70 CFM fan can do that, and then you conduct the pressure test. Now that pressure test used to be required regardless if you used option 1 or option 2. Now it's only a mandatory requirement if you're using option 2 here with the exhaust fan, but you'll see a lot of folks continuing to use it regardless of the test, because regardless of if you use option 1, this isolation method, because it turns out that you only get what you inspect, not what you expect. So you can't visually see if the garage is actually separated from the house. You've got to test it, you've got to ensure it, and it's a pretty important part of this program to ensure that you get that added level of safety and health by clearly separating the house from any attached garage here. From a verification perspective, it's laid out here on the verification checklist. This would be done by the rater only, either doing these tests as I described as well, as verifying how well it's visually separated from the house. We get reduced exposure to carbon monoxide as a benefit from this section. We ensure that pollutants inside our garage are completely isolated away from the conditioned living space of our houses, and we get round-the-clock peace of mind ultimately through this section of the code here. Low emissions materials. Now this is probably, this and radon probably are the biggest trouble sections for builders in our houses. Low emission materials primarily because we really need to start early in the process assessing what materials we're building in specific categories, and we'll go into that more. But you also have to remember, and I'll say this up front, is to document those materials that you're using. That's a huge part for verification and ensuring that you're meeting the requirements of the program. So the issue here is that the indoor levels of chemical pollutants inside our houses are 2 to 5 times higher inside our houses than outdoors. And we spend, as I said before, we spend so much time, up to 90% of our lifetime is spent indoors in this environment here. So we're looking at the issues of volatile organic compounds, or VOCs, and other chemicals that outgas into that environment that create eye, nose, and throat irritation, headaches, other even more damaging illnesses like liver and kidney diseases. All these types of things can be created by breathing repeatedly these chemicals that off-gas from the materials that we build with and that we bring into our homes. So the Indoor airPLUS program created this guide to help us better document the materials that are brought into our house, because they've had a requirement for a long time that we documented, but they never gave us this guidance until version 3 of the program here. This guidance document can be gotten on the EPA's website, the Indoor airPLUS website. When you pull the construction specifications and the verification checklist, you can get this document as well. VOC and this labeling process. So this is a really rapidly evolving field in indoor air quality. VOCs have been regulated under the Clean Air Act for a long time, but being able to document that regulation has been hard. Only the Clean Air Act has only been concerned about VOCs that react with sunlight to form ground level ozone in our air. And so the Clean Air Act has not been specifically looking at indoor air quality associated with volatile organic compounds until recently here. The ramifications are that early standards for low emission products only concerned with those exceeding the VOC limits, and those limits again were set from an ozone perspective instead of an indoor air quality perspective. So anyway, we need to ensure that we're following these new standards and these new guidelines to document the materials that we're putting inside of our houses here. The indoor air quality field is concerned with what people, particularly kids, are susceptible to these pollutants that they're breathing in our homes and our schools and in other buildings that we're in, again, 90% of our time during our lifetime. So they're looking at a specific class of volatile organic compounds, and that class of volatile organic compounds happens to be present in a lot of the building materials that we're using here. What goes in doesn't necessarily come out, which basically means that we're getting some of those materials that are being used in the manufacture of these products isn't necessarily off-gassing, but what we're really concerned about are those things that are off-gassing. There's some standards been set to prohibit specific volatile organic compounds into the construction of these materials. but it's not all over the board here. And we're getting better and better materials out there. But again, you can't, just because you're specifying it, you don't know what you're getting unless you're verifying what you're getting out there. Okay, I'll let you look at these other two statements here. The other thing that has been coming out recently is all the pollutants that have been that are created at the time of cooking here. So you see even formaldehydes, which you wouldn't think about, or these ultrafine products that you wouldn't think about, are happening when are being created just by the process of cooking and how we cook, the materials that we use to cook, the types of pans and cooking systems that we're using. And then there's this new effort to ensure that we have better and better kitchen ventilation. Now, the Indoor airPLUS, again, is mandating that you have at least that 6-inch duct and a 100 CFM fan in the kitchen. That's going to change sometime in the future, and we're going to start talking about what's called capture efficiency of that hood, and they might even mandate the type of cooking equipment that we use, because we're beginning to learn that electric resistance cooking is minimizing the pollutants that are created in our home versus using gas or other type of electric cooking systems here. So just from cooking food, depending on the food, you know, when you're cooking an egg, for example, you can get these types of things created as that food changes state from an egg's perspective, from a liquid to a more solid. It's releasing chemicals there. And again, this research is relatively new, and the way the Indoor airPLUS program is utilizing it right now is to ensure that we have proper kitchen ventilation here. Other things that are entering our built environment are being taken care of through source reduction here. And that's by utilizing third-party partner programs that are referenced in the Indoor airPLUS specification. They're trying to use these programs to document the reduction in VOCs and other pollutants that are brought into it. So the third-party standards help verify products' claims. They add credibility to manufactured claims that they're low-emission materials, for example. They increase transparency. They're based off of consensus standards, so usually they have a broad stakeholder input and support. They reduce this greenwashing. You know, people just trying to sell materials and say that they're healthy and they're able to be used in these types of healthy houses that we're trying to create here. And we see that the EPA does not establish emission limits for products used indoors. They're just leveraging these standards that have been created by these other labels here. So the Indoor airPLUS requirements provides a range of options there. Some of these options are really rigorous. Some are a relative low bar here, but the builder only needs to meet one of these standards per product category that we're going to be talking about here. In many cases, different industries and third-party labeling programs are actually certifying to the same underlying standard. So examples of those standards are this CARB or California, I forget what RB stands for, but it's a standard that comes from California Title 24 requirements here as an example. So this is the CARB standard. It's a California Air Resource Board. That's what it is, the California Air Resource Board. It establishes mandatory emission performance standards on particle boards, medium density fiber boards, and hardwood plywoods here. They're airborne toxins to reduce these emissions here. The phase 2 refers to a more stringent emission limit that has been created. Complying materials must be used in all finished goods materials, and compliant products must be labeled here. You can go to websites to get more information about the CARB 2 Phase 2 standard here. The carbon emission standards for formaldehydes, again, prior to the composite wood product regulation, formaldehyde emissions were often 10 to 20-fold higher than they are currently allowed in our homes now. And again, you can go to this fact sheet here to get more information here. There's other standards that have been developed as well, and you can find more information by going to the Indoor airPLUS specifications and the specification guide specific for materials, that is a supplemental guide as well, to learn more about these standards as well. But ultimately what we're looking for is in these product categories. So from composite woods to adhesives, to carpets and carpet adhesives and carpet pads, interior paints and all types of interior finishes, and hard surface flooring materials there. These are the types of products that we're trying to look at, to document, and to ensure that the source that we're bringing into the house isn't emitting very much into that house, or anything at all potentially into that house. So let's look at composite woods first. So it's if you use certified low formaldehyde products for all composite wood materials inside your home, they need to include things like structural panels, cabinetry, shelving, trim, doors, stair treads, flooring, all of these things. And, things that you don't normally think about, like stair treads that often use a particle board tread and a hard or a dimensional lumber for the stringer. That tread needs to be made with a compliant piece of particle board, or trim materials that are particle boards now, all these types of things. And then other standards for structural products like structural plywood and hardwood plywood and particle boards and MDF, cabinetry, all these things need to be looked at here. So this is an example of the guide that has been created. So in this case, we're looking at structural plywood and oriented strand board, and it tells you what standards need to be met, the PS 109 or the PS 210 standards, and it gives you an example of what that document might look like on a piece of wood. And you might have to take a picture of that or get that from your material supplier and retain that documentation and give it to your third-party verifier here. So here's an example. You can see that this has the PS 2-10 single floor stamp on it down at the bottom, and it's giving you its exposure rating at the top there. So that's the type of documentation that needs to be gathered for this type of material here. This one's for hardwood floors in the guide. It's giving you this HPVA stamp that you're looking for, and you can see here that it's CARB documented here, and then over to the right there's a flyer for that particular piece of hardwood plywood that says that it's CARB Phase 2 certified there. Here's another example for hardwood flooring. It's a composite product that's HPV certified and CARB Phase 2 certified as well. For particle boards, you're talking about Green Guard certification, and they're Green Guard or CARB 2 compliant systems out or materials out on the marketplace that you can find. A lot of, in the Denver area, this program has become more and more popular, so more and more suppliers understand what the documentation that they need to provide. In Summit County, it might be difficult at first to get the right documentation for the materials. And again, that's one of the reasons why you need to start early in this process, specifying the material and ensuring that it's properly documented before it goes into the house here. MDF woods, eco-certified stamp on that piece of MDF wood, ensuring that it works. Here's a wainscot coating that's CARB 2 compliant here. A piece of flooring material that has a Green Guard label on it. So more and more of these materials have that type of labeling already on it here. Cabinetry is one of the big ones. Not all cabinet manufacturers use low emission materials in their base structure of the cabinets. They're particle boards. So you need to think about making sure that your cabinet manufacturer is using the right base materials here. Here's one that has the KCMA certification on it. Here's a piece of cabinetry that has a label on it as well. California P2 compliant for formaldehyde on it. So the Indoor airPLUS compliant program is looking for that we have no added formaldehyde. These are some of the different acronyms that you might find on the labeling there. The ULEF or emission, and the emissions are consistent with phase 2 standards here. And you can look at this section as well. It's all in that guide there. But the real point here is that everything needs to be documented. All these materials need to be documented inside before they're installed inside your home there. For interior paints, at least 90% of the interior surface area covered with site-applied paints and coatings shall use low VOC or no VOC products certified by one of the following third-party standards. So there are a variety of standards from GreenGuard to Green Seal to GreenWise that you can use, or the MPI standards to use to certify that. Again, that's talked about in the interior paint section of this guide that accompanies the Indoor airPLUS program. Here's some other certificates or labels that you can look for and how they're used on paints. Here's an example of how it's used on this Valspar paint product as well. So this has a label on it. We're wondering if it's compliant. It says MPI certified, but we don't know exactly what that number is here. So you might have to go to a website for the MPI certification website and find out, is number 361750 a compliant standard? And you go to there and you see that MPI number 15 is a compliant latex interior paint system here. So verification could be a multi-step process as well there. But there are websites like this website and the other website that can help you determine if the product is compliant or not here. So this is all a rater verified section here. The documentation, however, really has to come from the builder in order to verify these materials. Carpet pads and carpet adhesives, again, this 90% rule, at least 90% of the surface that's covered with carpets need to be certified, in this case using the Green Labels Plus certification program here. Again, we have somebody unmuted there. So this product comes directly from Home Depot. So even Home Depot is carrying products that are certified that could be used in our houses here. CRI Green Label Plus approved for low VOC. Here's one that has a label on it for the CRI certification. Another example. So there are a lot of products out there that are meeting the certification labeling here. Now you just need to look for it and then retain that documentation, because that documentation is going to be verified here. So again, for carpets, this carpet could be builder verified, but that builder verification comes through documentation there. That's really the only way to document it here. So while there's an advisory in this section for adhesives and sealants. Again, the 90% rule is covering 90% of the surfaces that are using that material. It needs to be low VOC or no VOC products. So here are adhesive sealants that are labeled with the GreenGuard sealant, another GreenGuard sealant label. All these things are working and working for. For hardwood floor surfaces, again, that 90% rule, are looking at it. If you can't find the product, here's a website that you can go to to look for, adhesives, cabinetry, components, and whatnot. So the ultimate benefits of this is reducing the chemical load inside that house, lowering exposure to the volatile organic compounds, and reducing potential for the occupant's health concerns that might arise through exposure. The one thing that it doesn't do is it doesn't limit what the buyer brings into the home. So again, consumer education is super important because the particle boards and whatnot that are used for the substrates of couches and other furnitures are hugely off-gassing materials into our houses, let alone what we might be bringing in on our feet with our shoes into the houses here. One way to document everything that's being brought into the house is a system that I've often used with builders to demonstrate compliances. Starting earlier, create a tabbed binder, a tab for each product category. So a tab for stairs, a tab for cabinets, a tab for carpets, a tab for paints. Collect and store the documentation in this binder for the materials that you're going to use. And then the rater can come in and verify the binder at one time. It usually takes about an hour to verify all the materials that you're planning to use in that house. This streamlines the process. It makes it really useful. And it gives you documentation that you can use time and time again if you're using the same specifications for each of the house. Now, if you're doing a project, if you're doing a more custom project, you're going to need a binder per project. If you're doing a more production environment, you need only one binder per project or per community that you're building in, as long as the specifications are the same across that community for multiple houses there. But this binder really makes this process much more streamlined and straightforward. Okay, so the last section we're going to talk about here is this home commissioning section. So this is verifying that the HVAC system and the ductwork are installed according to their design, and ultimately that ductwork is free of dust and has been cleaned after the house has been built. I just took a picture of a piece of duct that it was amazing how much dirt, let alone food wrappers and other things that were inside that duct. And that house had already closed and was about to be turned over. It's kind of disgusting there. So making sure that this part of the program gets implemented is super important because it's not something that's happening regularly out there in the field. Again, this is something that the rater would verify, usually verifying it at final through an inspection process here. Ventilation of the home with outside air at the highest ventilation rate possible during before the house is turned over. So in essence, what they're asking for is that you utilize the ventilation system or open all the windows in that house for a period of time to allow anything that might off-gas to off-gas ideally as fully as possible before the occupants actually move into that house. So that's what this requirement is asking for. This can be either builder or rater verified. You want to do it shortly after installing the building products, during the period usually between finishing and occupancy at some point, and you need to maintain some type of record that it's been done so that it can be verified and marked off on the checklist that's been done. So it's something that you might be able to verify and throw in the binder, how you're going to actually do that there. The owner resident information kit. So this is like an owner's manual that needs to be provided to the home buyer. It provides the residents and building owner all the information about what's happened with that house. So it provides the indoor label, it provides the certificate, it provides operation and maintenance instructions, and all the manuals that have been gathered through the process for your HVAC systems, your ventilation systems, your radon systems, and it helps better ensure that some level of customer buyer training is taking place so that they understand how to maintain these systems. They understand how these systems are meant to function, that they shouldn't turn off their controlled whole house mechanical ventilation system, for example, or that they need to change filters on a regular basis, and this is the type of filter that's recommended. This type of education is super important. It's something that doesn't happen on a regular basis, and it's a mandatory requirement of not only now the Indoor airPLUS program, but the DOE Zero Energy Ready Home program, and therefore code. It can be verified either by the builder or rater. Again, we want to retain some type of copy here describing how it's done, potentially putting it in that binder. All those things would be good ways of doing that. And then thinking about how are you going to transfer these certificates and labels to the home buyer. Not only the Indoor airPLUS label and certificate, but the Energy Star label, the DOE Zero Energy Ready Home label. Often these labels come to you as the builder or verifier after the house is already closed. So I often say that it's a good time to take these labels to your home buyer when you're doing a 60 or 90-day walk on that house to double check if there are any other issues with the house, last issues that create a punch list. It's another time to reinforce the sale and demonstrate all the value that you've added in that house by displaying and giving these certificates and actually installing these certificates into the house. Finally, both the rater and the builder need to sign the checklist and verification checklist for this program and ultimately provide a copy of that checklist to the buyer themselves. So that checklist looks like this. The label would go next to the Energy Star label, either at the electrical panel or some other permanent location in the house there. And so all the labels can go in the same location, but it's important to get those labels installed and thinking about how you're going to do that. So that's why I conclude by saying you need to start early in this process of thinking about how you're going to implement not only this program, but now this new code requirement, because there's a lot to think about. It's going to change in some way or another how you build your houses. So thinking about that design integration meeting and talking about all of this during that design integration meetings up front will help you. Understanding these programs early, looking at the commonality in all these programs. So getting those documentation off of the websites, spending some time with it, looking at the overlapping requirements so that you're not trying to do things 2 or 3 times when actually it's just one requirement that's common throughout the whole program. All of that becomes important to think about and start that thinking process early. Collect that verification information as you go in this process. Trying to collect it at the end of the process, I haven't seen anyone successfully do it yet. But if you create this binder and you're putting the information in the binder as you go, it makes it very simple, and then you just turn that binder over to your rater. They can quickly verify it, and you can move forward there. You get ultimately from the program what you want, but ultimately you can get a lot from this program if you go through the process and partner with not only the Indoor airPLUS program, but Energy Star and the DOE program. You get some brand identity there. You can take advantage of all the program marketing support documents and websites and other things that they have that you can take advantage of. So you know, it's a lot to do, so you want to get what you can from these programs and this effort that you're putting forward to make these programs successful and make sure that your house is compliant with the new code there. So as always, I am available if you have questions or concerns or just want to shoot the breeze. Don't hesitate to reach out and ask me anything, and I will stay on and answer any questions that have come up as well.
Thanks, Robbie. Yeah, as Robbie said, feel free to unmute yourself or write in the chat if you have any questions. It does look like we've got one question here from 1.1. Where are sump pumps required in Energy Star?
Sump pumps are part of, there's not a mandatory requirement. It's part of your foundation drainage system. If you choose to use a sump pump as part of your foundation drainage system, then that's when you need to get to a point of making sure that that sump pump is air sealed so that any air below the foundation isn't mixing with air inside the conditioned envelope of the house. But it's not a mandatory requirement.
Okay, I've got another one for you from 5.4 pressure testing. How do you recommend getting hoses through the sealed garage door to conduct the reference reading?
I happen to use Energy Conservatory equipment, and Energy Conservatory pressure gauge comes with a little metal tube that you put into your pressure hose, and the metal tube will fit easily between the door and the threshold, the weather stripping at the threshold there. You can get this metal tube between those two locations so that you can measure the pressure in the house in reference, you can measure the pressure in the garage in reference to the house.
Great, thank you. Yeah, and I just had a question. I mean, thinking about other rating systems like WELL and LEED, you know, they take into consideration the furniture that's being put into the home. So this is purely building components and not furniture. Just wanted to confirm.
Correct. Yeah. Yeah.
Okay.
But like I said, I think it's a great opportunity at that customer education phase of this program to include that and make sure that people moving into the house realize what you've done and what they can do to undo what you've done by bringing in furniture that has huge off-gassing potential.
Yeah, definitely. Okay, I've got one more for you from 6.2. Have you seen any approved stains?
I know there are approved stains. I can't give you a manufacturer off the top of my head, though.
Yeah,
so yes, I've seen them, but I don't know. But I can't give you a name.
We'll post the slides to this as well, where Robbie referenced some of those websites to use. So you can go on there and check if there's any stains that are available or what stains are. Okay, for the Zero Energy Ready program, what is the final submission documentation? The checklist,
for code compliance, the certificate. So at permitting, you need to submit the proposed certificate and HERS target document for the program so that it demonstrates that what you've designed and you propose to build is compliant with the program. So you'll have a proposed document, and then for your certificate of occupancy at the end, you need to submit the confirmed certificate, DOE Zero Energy Ready certificate for your certificate of occupancy. We talked about that at one, I think the first presentation, and you can go back to those slides that are posted in the DOE Zero Energy Ready overview session that we did, and it's discussed in more depth there.
Great, thanks, Robbie. Robbie and I will stay on the line for another couple of minutes if any other questions do come in, but for now, I think that's the end of the webinar, so thank you everyone for attending. Yep, and Jess just commented that people can just consult their local building officials to confirm what submission documents are required too, just to make sure you're getting all that you need into the building official.